I left off the other day, and the thing I left off on was the law of large numbers. So I want to make sure you write that down. I don't think we got to this slide. We were getting to it. And I went over the law of large numbers, and it basically means that the more numbers you do, the better off you are, whether that's statistics or probability or whatever the case may be. If you want to make sure your data is valid, you need to use more numbers than you think. Now, as you get into statistics and probability later on in other courses, you will get to what's called the confidence levels, and that determines how big of a survey or questionnaire or how many people that you actually have to do. So you're not going to know that in this introductory chapter, okay? You're only doing 2 sections in 11 and 4 sections in 12, so you're not going to get that. But what they're wanting you to realize is that in probability and statistics, the more people you survey, the better. Or the more people you question, the better. Or the more samples you pull, the better. Okay, so the law of large numbers states that the probability statements apply in practice to a large number of trials, not to a single trial. It is the relative frequency over the long run that is accurately predictable. All of that means the more numbers, the better. Okay, so that's what that means. And we'd already talked about that a little bit, so we're going to move on. All right, here's the example. There was a couple of students at MIT a while back, and they took a roll of quarters, and they measured those roll of quarters. They weighed them. They did infrared scans. They checked the balance of each one of those quarters in a roll of quarters, which is what, 40 quarters? And they took all those 40 quarters and they made one quarter in the computer. They algorithmically generated one quarter that's based on those averages of the 40 quarters. And they wrote a program in the computer to flip that quarter just like you would a regular coin. And the reason they wanted to do it is they were trying to see how many flips it would take for the quarter, the physical probability, to match the theoretical probability. Because the theoretical probability of tails is 0.5, or heads is 0.5. So they wanted to know how many times they flipped it. So they flipped it 10 times, and they came up with 4 out of 10 flips is 0.4. which is not equal to 0.5. And then they flipped it 100 times, and it became 0.45. They flipped it 1,000 times, 0.546. They flipped it 10,000 times, 0.485. So they finally flipped it 100,000 times, and they got 0.4977. So that is the number. That is the large number rule and explanation right there. The larger the number of tries, the more the physical probability actually gets close to the theoretical probability. And that's a good slide right there. So you might want to make a note of that when you're watching this video. You might want to make a note of that. That's a good slide because that basically explains the law of large numbers. Okay? Okay, they're said to be equally likely. I'm not going to go over that. Again, how do you find the probability, the number of outcomes over the total possible number of outcomes? Remember, the theoretical probability, let's do some theoretical probabilities. They're easy to do because you don't have to have a coin. You don't have to have a deck of cards. What's the probability of a king out of a deck of cards? 4 out of what? 52, which is 1 out of 13. Nobody has a deck of cards. What's the probability of finding a 6 or rolling a 6 on a die?
1 out of 6.
1 out of 6, because there's 6 numbers on a die. What's the probability of rolling a 0 on a die?
0 out of 6.
0.
Or 7? 0 or 7? 0%, because there's no 0 and there's no 7 on a die. Okay? What's the probability of a face card in a deck of cards? That would be 12. Yeah. 12 out of 52. Whatever that reduces down to. Okay? So I just did three different probabilities, and I don't have a deck of cards and I don't have a die. So that means they're theoretical. They're based on the mathematics. They're based on not rolling. They're based on the mathematics. And then it's the same thing. The number of times something actually happens over the number of times something can happen. The physical probability, if you threw a die 10 times and it came up, a 6 out of those 10 times, that would be 1 out of 6, 1 out of 10. So, it changes. And that's why the numbers are not the same. And that's why you have the large number rule. Okay, a fair die is rolled. Find the probability. Okay, we just did that because we have theoretical probability, not physical probability. But 2, well, that'd be 1 out of 6. Probability of 2 is 1 out of 6. The probability of even number is 3 out of what? 6. A number greater than 3, that would be 4, 5, or 6. 3 out of 6. Which you would reduce these. I'm not worried about reducing them. Probability of a 7, 0 out of 6. A number less than 7, 1. Because what numbers are less than 7 on a die? All of them. 6 out of 6, which is 1. Those are 5 good test questions right there, along with the 3 I just did on the previous slide. So you got 10 questions right there from 11.1. Uh-oh, Mr. Hudson must have left. And Ms. Latimer, are you still there?
Yes, sir.
Okay, just checking. All right, number of outcomes that result in, what is this? Determining theoretical. Okay, this is what we just did. I'm not going to go over that. We just did that. The probability of an event that cannot occur is 0. Does that mean it's impossible? No. Remember birth control. They say that some birth control is like 100% or 99.7. That doesn't mean it can't happen. Nothing is impossible, okay? There's a question on a lot of standardized tests that says, well, the probability of blah, blah, blah come up to be 0. Is it impossible? The answer is what? No. Nothing is impossible, okay? Especially when you're talking about an event. An event can occur, okay? The probability of an event that must occur is 1. Does that mean it's going to happen? No. So it's a very high probability that it's going to happen, but it doesn't mean that it has to. And most probabilities fall between 0 and what? 1, which means a decimal, okay? The sum of all probabilities must equal 1. So if you add up all the probabilities, they have to equal 1. This is what we left off with the other day. The word for the other side is called complement. They're probably going to put that on here somewhere. No. That right there is a complement. So you might want to write it down. Complement. Very important that you understand complement. I'm going to give you some examples of complement. If I tell you that there's 100 people in my class and 30 of them are very smart, then what does that leave?
The 70 that aren't.
70 are not very smart. And I put an X through that. In other words, if I have 100 and I tell you that 30 are smart, then that means 70 are not smart. What is the probability? And most probabilities equal 1, right? So if I tell you the probability of tails is equal to 0.25, then that means the probability of heads is equal to what? I'm sorry, 0.25.
0.75.
So the probability of heads is what?
0.75.
0.75. The complement is what?
It's left over.
Makes up the whole, or what is left over, yes. Remember that. But the whole can be several different things. The whole can be 1, or it can be 100%, or it can be 100 students, or 255 employees with 55 being sick. How many are not sick?
200.
200 are not sick. So when you're talking about the complement, you could equal 100%, you could equal 1, or you could equal how many employees, the total number of employees. So, and the way that you see the complement, probability of an event plus the probability of the event not happening, which is a line over it, is equal to 1. This right here is the complement. Hold on a second. That right there is what we call the complement. So if you ever want to find the complement, you subtract the probability that's given away from 1, or away from the total, like in the example would be the class, 100% of the students are smart, 30 are smart out of 100, that means 70 are not smart. 255 employees, 55 turn in sick, 200 are not sick. Those are totals. But in probability, your total is going to equal 1 a lot of the time. That's why they say 1 on this slide. Okay, here is a deck of 52 cards. 52 is a standard playing. That's when you take the jokers out and you're left with just the cards. There's 4 suits. There's 13 cards to a suit. 4 times 13 is 52. Face cards are also called picture cards. I've never heard them called picture cards in my lifetime. I've always heard them called face cards. So that's a standard deck. Now I have to show that because some people don't know what a standard deck is. Don't ask. I don't know. They don't. Okay? A deck consists of 4 suits, blah, 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 blah. I don't need to go over that again. Blah, 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 blah. Determine the probability that the card selected is. Okay, an 8. How many 8s are there in the deck?
4.
4, so it'd be 4 out of 52. All these are reduced as needed. I'm not going to reduce them because y'all are in college. I think y'all can reduce 4 over 52. Okay? What's not 8? If 8 is 4 over 52, this is a complement. What's the complement of 8? Not 8, which is 48 out of what?
52.
52. A club. How many clubs are there?
It's 13.
13 out of 52. Reduce if needed. I'm going to put an R here, meaning you need to reduce. And you reduce here too. Okay? A jack or queen or king, a face card. That would be what? 12 out of what?
52.
52, because there's 4 suits, 3 face cards. So 4 times 3 is 12. Heart and spade. Okay, technically they should not be asking these because we haven't went over the rules yet. But,
26 out of 52 or no?
well, they're only picking one card. So and would be 0. Why?
I see. Because you only pick one card, is that what
You
you're
only
saying?
pick one card. You can't have 2 cards
Right.
if you only pick one card. A card greater than 5, oh God, and less than 9, 0. Because it's asking you to pick 2 cards.
So anytime it says and, that means that it's 0.
It's 0 because you can't pick 2 cards. That's kind of a trick question. So let's see what they get for E and F, because technically you can't do E and F if you're only picking. Let me check the directions. Look there, 1. Let's take that dang old highlighter and let's highlight that. One card. They should get the same thing if you reduce 48 over 52. You should get the same thing. $13 over 52. 3 out of 13. I got 12 out of 52. That's reduced. Huh? Look at there. It's not possible. No, that's not correct. You cannot. Okay, I see what it's asking. Okay, I misspoke. The and, you're not picking 2 cards. I'm sorry. A card greater than 5, which would be 6, 7, and 8. So that's 3 times 12. 3 times 4 is 12. Be 12 over 52. I read the question wrong. I thought the and meant picking 2 cards. My bad. Okay. And that's how you do, what did I say, 11.1 or 12.1?
It's 11.1.
Huh?
I think it's 11.1.
Yeah, 11.1. So let's look at 11.2. I don't know how to pull up 11. Well, let me just go back to the, there we go. 11.2. This is probably going to be odds. Yep. Okay, I'm just going to go straight. I'm not going to do the first 3 because they're going to confuse you, so I'm not going to the first 3 slides. I'm going to, there is the odds against. Odds against is probability of failure over the probability of success. Odds against is equal to probability of failure over probability of success. And I also want to leave things in the form of a fraction because the math is easier. Okay? When you're doing odds against, make sure you leave everything in the terms of a fraction because it's easier to actually do the math because you're multiplying by the reciprocal.
Okay, so
Yeah,
is
just
that
like
what's that beside the O? Is that like an A?
an A. It's supposed to be an A, but the little line didn't. Odds against. Just write that down. You don't need to write all this because that's just confusing. The probability of failure over the probability of success. Probability of failure over the probability of success.
Is that N minus 1 and then where F is? Is that A minus? I can't see. It's not like irregular like it normally is. So it just shows the slide big and you're in the little corner. It shows like Anderson campus, then Miss Latimer, and Oconee, and then so it's weird.
Hold the camera up and let me see it.
What do you mean hold the camera up?
Just tilt it back a little bit. Can you tilt it back?
Yeah.
Keep going. No, tilt it back. Tilt it back. Oh, that's okay. Forget it. It's going the wrong way. I don't know how you tilt it. Okay. It should say probability of failure over the probability of success.
Yes. What's the little letters beside the F and the little letters beside the F?
Fraction. Oh, fail. F-A-I-L.
Oh, okay.
Over the probability of SUC, success.
Okay.
Now, the question will ask you, what is probability of success? Okay, here it is. Determine the odds against rolling a 4 on a roll of a die. Okay, here we go. 4 over 6 is success. Probability of success is 4 over 6. So establish that first. Probability of success is equal to 4 over 6, which is equal to 2 over what? 3. Now, why is that success? Because the question is basically saying, if you roll a 4, you what? You win. Win is success. Now, whenever a question asks you about rolling something or about winning, that is success. If you pick a king, that is success. So therefore, the probability of failure is equal to 2 over 6, which is equal to what? 1 over 3. So the odds against is equal to the probability of failure over the probability of success. So what does that equal? 1/3 over what?
2/3.
2/3. So how do we divide by a fraction? We multiply by the what?
Reciprocal.
Huh?
What are you talking about?
Reciprocal?
The reciprocal?
And what happens to the 3's?
They'll go, you mark them out. It's cross
And you
out.
get 1 over 2, or 1 to 2, or 1 to 2. Those are your 3 forms of the answer.
1 over 2. 1 to 2.
Oh, Lord. I'm sorry. The probability of rolling a 4 is not 4 over 6. The probability of rolling a 4 is 1 out of 6. I messed up. Hold on, just let me erase the whole thing. I'm sorry. Let me start over. The probability of rolling a 4 is 1 out of 6. Therefore, the probability of not rolling a 4 is what? 5 out of 6. There we go. Now, the odds against is equal to the probability of failure over the probability of success, which is equal to 5 out of 6 divided by 1 out of 6 multiplied by 6 over 1. And what happens to the 6's? You get 5 over 1, or 5 to 1, or 5:1. Now, what do you do with that? Well, let's say that you put a $50 bet. Let's just put a line right here. Let's say you put a $50 bet on rolling a 4. $50 bet on rolling a 4. what happens if you roll a 4? Do you win or do you lose?
Win.
You win. So that would be $50 times 5 over 1, which is 5, which is equal to what?
250.
So if you hit a 4 on the die and you bet a $50 bet with 5 to 1 odds, you win $250, which means you won $200. You get your $50 back, but you won $200. That's how you do odds against. My bad, I had a brain bubble there for a moment. I only teach like 3 of these classes a day. I don't know why I can't. Oh. Okay.
I was picking up what you were putting down, so it's okay.
Thank you. 5 to 1. Okay. Now I'm not going to go over the odds in favor because you know why? What is the reciprocal of odds against?
Odds in favor is the same.
So let's go over that. I'm not going to go over this. I'm just going to ask you if the odds against in the last problem was 5 to 1 or 5 over 1, then what would be the odds in favor of that last problem?
1 to 5 or
1 to 5 or 1 over 5. The odds in favor is the reciprocal of odds what?
Against.
Of the odds against. I'm not going to spend a lot of time. A lot of people say, why don't you? Because you don't. Nobody asks for the odds in favor. Nobody. Because the only thing you do for odds is gambling. And that's why you always ask for the odds against. Nobody ever asks for the odds in favor. Unless they make up a problem, which they will, for example. The circle graph shows the U.S. smartphone ownership in 2014. I have no idea where they're going with this. But it says this. Dang, oh, I'm a Samsung. Dang, oh, S10. Dang, oh, Samsung. All right? If a smartphone owner is randomly selected, determine the odds against the individual owning a Samsung. Well, I guess we're going to go over 100. So the odds, when you're doing odds against and odds in favor, you've got to establish success and failure. So what is this one asking? Let's take our green marker and what is winning? What is success?
Samsung.
Samsung. So somebody tell me, what is the fraction for Samsung?
27 out of 100.
Okay, probability of success is 27 over 100. Therefore, the probability of failure or not success or failure is equal to what? 73 over 100. Now, what are they asking for? The odds what?
The odds against.
So that's probability of failure over the probability of success. Multiply by the reciprocal. And it is 73 over what? 27. Now, I'm not going to reduce that, and you can reduce it into a decimal if you want to, but I'm not going to. Y'all can do that. So when you're doing odds against and odds in favor, you have to establish what?
What is what? Is in favor? Yeah.
And what is the odds in favor?
The odds in favor is the 27 over 100.
73, good.
You know what I was saying.
I appreciate it. 73 over 27. a circle graph, blah, blah, blah. If a smartphone owner is randomly selected, determine the odds against.
Individual who has
I think
a
we just did that. Did we not just do that? Yeah, 73 over 27. Huh? Okay, I don't understand what that was. All right. The odds against Robin being admitted to the college of her choice are 9-2. Determine the probability that Robin is admitted and the probability, okay. The odds against Robin being admitted is blank, okay, 9. First of all, 9 over 11 over 2 over 11. How did I get that number? What is probability? What is odds against? Odds against is equal to the probability of failure over the probability of what?
Success.
So that's going to be 9 over 11 over 2 over 11. So what is the probability of her getting into the college that she wants? 2 over 11, because that would be probability of success. So 2 over 11 is her probability that she's getting into a college that she wants. The odds against Robin being admitted to the college of what? Of her choice. 2 over 11. Somebody's supposed to ask me where did I get the 11.
You got it from 2 plus 9. So
Thank you.
We're the only ones here except for Miss Latimer.
I know, but I have to ask that because somebody always asks that question. Where'd you get the 11? So the answer is 2 over 11. That's it. We've just done Unit 3. Well, Unit 4 technically, because Unit 3 y'all working on your own. Da 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 da. So we're done.
Does Unit 3 have a test?
Yes.
What is that?
You on the last day of class? Should say that.
Okay.
All right. Y'all need to be working on 11.1, 11.2, 12.1, 12.2, 12.3, 12.4, and we will go over homework questions or the test Wednesday. Y'all got that?
Yes.
All right. Y'all have a good day. I'll see y'all Wednesday. Hopefully see Easley Wednesday too. They had their phone cut again. So see y'all.